Hello everyone, welcome to Bootcamp. Just let's hop in for the start. Can we stop the video? Anyone from the
Okay.
So have we started? Sorry for my internet
Yeah.
got disconnected for a moment. Okay. So
Yeah,
hello
we have.
everyone. Okay, you have started. Okay, then let's just continue with the application.
Fine. So let's start with the third session of this bootcamp. Now, before the session, let's take a look at what we have been covering till now. We we started with not even blockchain. We started with some of the concepts that are always needed before studying blockchain development, some cryptography stuff and all. And then uh, we came across different consensus protocols that are very popular, and we also learned about inside the block that how does the data that's inside the block works, some of the basic stuff, and much of the stuff was theoretical. Like we got to learn so many new things, but all of them were just verbal. I just showed you through some slide and some only some small demos. That was it. But from today, we are coming to the practical things, some real world, how things happen in the real world, how to use things, how you interact with it. From today, you'll start to know about uh, blockchain applications that we generally use and how to develop them. What are the things that are needed to develop them, and so and so. So until now, if you guys have any doubts, like from cryptography, from consensus protocol, from blockchain properties, from any of the topic that have been covered so far, if you have any doubt, you can ask that, and after covering all of those, then we can proceed from the further topics.
I guess we have moved out to history from this YouTube side.
Okay,
With that, we can proceed. Okay.
okay. So let's proceed then. Fine. So when we come to the real applications using blockchain, we have already seen some of the properties that blockchain technology offers, and um, these properties can be used at many places that we saw in the previous slides. Now, before even jumping to the blockchain development stuff, I think it would be a good idea to at least take a look at how these applications are used and how they are uh, how basically people use it, right? So one thing that we always need to know is that whenever you want to interact with a blockchain, which is called a transaction, so whenever you want to make some transaction, make some new addition to the blockchain, you need a wallet for that. Now, what is a wallet? A very basic definition of wallet is some kind of small software which stores your public key and private key and makes it secure and use them to generate transactions, sign it, and send it to the blockchain. So whenever you want to make any addition into the blockchain, we have already learned that we need to sign it using our private key. And I mean, it's all cryptographic. You cannot do it manually. You need some kind of a software. So wallet does that job. Wallet wallet is responsible to store your private key in a very secure manner. So if you are using some kind of software, it will store your private key into your computer's memory, encrypted and safe, and it will also broadcast your public key to the whole network, to the whole world, and it will also uh, try to use both of the keys whenever required. So, for example, whenever you are making some transaction, then it will generate a complete code of that transaction, that what is basically happening within this transaction. It will sign that transaction using your private key, and then it will send that operation, that transaction, to the blockchain. All of this stuff is done by a wallet, and wallets are always responsible for securely doing this. So the first thing that we need to know now is how wallets basically work. If you are going to develop blockchain applications, you need to know how they work. So that's the first thing we are going to do. We are going to look at a wallet. We will try to go through the features that a wallet offers, and that will hopefully make you familiar that how does it actually work. Okay, so we are mostly covering uh, everything with Tezos blockchain. So every blockchain have uh, its own kind of supported wallet for it. For example, we have Bitcoin wallets, then we got MetaMask wallets for Ethereum. We got Temple wallet for Tezos, and if we can also have multiple wallets for single blockchain. So for Tezos, we got Temple wallets also, and we got Nan wallet also. Plus, there are some physical wallet also, like Ledger or Trezor. These are the types of wallet which are physical pen drive looking device which are connected through USB, and your private key is always stored within that hardware, within that pen drive kind of device, and it doesn't leave um, throughout its lifetime. The private key will always be stored in the device and will not leave ever. If you need to sign any kind of transaction into the hardware using the hardware wallet, you need to send a transaction into the hardware. The hardware will do the job of signing it, and then it will send you back the signed transaction, and that way you will use it. So the private key will not leave the hardware wallet ever, which is even more secure. But we'll probably not cover that. Uh, Almost all of them was the same way. So for Tezos, we are going to um, look at Temple Wallet. Temple Wallet is one of the most popular wallet for Tezos. Um, just simply go to templeWallet.com. I have some wallet already. I'm just removing it so that I can show you the whole process. Okay. So this is Temple Wallet website, and it's very easy to use. It have its own mobile app. Actually, it's going to come, but we generally use it using the browser extension. So if you are using some Chromium browser like Google Chrome, Brave, Firefox, which is about to come, you're using a Chromium browser, so you can easily go to the web store and download. So I'll just click on download and specify my browser. Yeah, Opera, Microsoft Edge. So I got Brave. Let's go to the installation link. So this is the page for Temple Wallet. I'll just add it here. Add extension. And in no time it will be downloaded and installed. Okay. So once the wallet is installed, you have two options. One is to import some existing wallet, and the other one is to just create a new one. So most likely, if you are just beginning with it, you are going to create a new one, right? Now, some more things. Whenever you create a new wallet, a new set of uh, private key and public key is generated, a new pair of it, and that pair is um, probabilistically speaking, it's never the same for it's never the same keys in anywhere in the world. So it's mostly a very unique key, right? Distinct and unique. And uh, this private key is a very long string. We have already seen that. Like yesterday, we generated a private and public key using RSA algorithm, and we already saw that how kind of complex that key was. It was a bunch of letters and numbers and symbols, and it's very hard to remember them. It's even very hard to write it, right? So this is a problem when I mean it makes it difficult for humans to kind of remember the private key, right? So there's a solution for that. We have generated a kind of algorithm which converts a set of words, mostly 24 words, and it converts those words to a private key. So how that happened, I'll show you. So whenever you create a new wallet, you first of all you need to enter a password. Okay, so I'll just enter a password and make sure it's a strong one. And it will be good if you keep following with me. We have that much time, so you can go to Temple Wallet and download it and set it up along with me. If you have any kind of question in between, feel free to ask right away and I'll answer it. So I entered the password, right? I'll create it, and yeah. Now, so this is what what I just explained to you about 24 words. A seed phrase is a set of 24 words which will help. So a seed phrase is a kind of a set of words which uh, on which if we apply some algorithm, it will generate a private key. So that is a seed phrase, and it's required because you can easily remember the seed phrase, and just a second, okay. Yeah, back. Fine. So let's try to do it practically and you'll get to it. So this is the sentence. Old gospel, neither ignore base, gun, else, place, remain, leave, carry, average. I mean, it's kind of, it's plain English and it's kind of easy to remember it. If you try it, then you will probably remember it sometime. And that's very easy because then you can always write it down somewhere or remember it. And whenever you need to import it somewhere else, import your wallet somewhere else, you will just enter your seed phrase. And the wallet will again take that seed phrase, you apply the algorithm to it and generate the same private key, which will be generated here. So that way it will be very easy to uh, learn your wallet or your private key. It's a replacement of learning your private key. You don't need to worry about any private key. You just need to worry about some couple of words. So that is the point of seed phrases. And whenever you create a new wallet, a seed phrase will be generated. And make sure that this seed phrase is not leaked, is not shared with anyone. It should be only with you. Here I'm doing some foolish things that sharing this seed phrase to you all, but it's probably going to be just a test wallet, so I don't worry about that. Make sure whenever you create a seed phrase, you back it up somewhere. Maybe write it down and place that paper or some kind of uh, file in your computer, which is not recommended. It's always recommended to write it down somewhere and place it at a very secure location. So because that's the only control to your assets, you don't want to give it to anyone else, and you definitely never want to lose it, because then you will lose the access to your assets, to your cryptocurrencies, which is basically pure loss, right? So when you have created a seed phrase, you have written it, you check this box and continue. Now, when you click continue, the wallet will use this seed phrase to generate the key pair. Okay. And yeah, one more thing, it verifies that you have written it. I haven't, so I have to go back and okay, do the complete process again. We need to, it kind of validates that you have back, you have a backup of that seed phrase. I'll just take a photograph of it because I don't have time to write it. And then you need to use the backup to fill in the blanks so that it can verify that you have actually backed it. Okay, so yeah, finish. Now when you finish it, it have verified that I have written it, and then it will use that seed phrase to generate the public and private keys, which will be all handled by the software in a very secure manner. You don't have to worry about it. And then it will show you some kind of an onboarding procedure. I'll just explain it to you in simple words. So whenever you create a wallet, the public key of that wallet is hashed using some algorithm, and that public key is hashed, and the value that you get after hashing is called your wallet address. Now, wallet address is a unique string which is used to kind of uniquely identify someone's wallet. So, for example, if I need to send some bitcoins to my friend, then I'll just ask my friend's wallet address. I'll take that address and send the coins to that address. That is the point of address. Okay. And anyone, like, I can even show you that. Just a second. Yesterday we looked at TZKT. So we looked at a transaction that someone was transferring this much coins to some other person. So go to the latest block, look at the operations, and here you can just, yeah, here you can look at a simple transaction. This is an address which send 12 Tez to this person. So this was a simple transaction. So this is the point of addresses, and we look at that in just a few minutes. How to start? Well, whenever you're creating a wallet on the main network of node, um, your wallet will be empty. Your wallet is always empty, right? Because obviously, whenever you create a wallet, it's not going to have any tokens. It's completely new. So you need to buy the tokens from some place. Now that place is generally some exchange, maybe Binance or BuzzFeed, whatever exchange you want to use, or you can use some other methods which generally wallets provide or the network provides. So we'll look what we can do here. We have other tokens also. So blockchains which support smart contracts can have other kind of tokens also. For example, Bitcoin doesn't, so there's only Bitcoin in the blockchain. But in case of Ethereum, there are thousands and thousands of tokens. In Tezos also, there are so many tokens. So you can also hold other tokens too using your wallet. And also we can create profile and all. And one more thing that I will tell you is the assets, which is basically some cryptocurrency or some tokens, they are not stored in your wallet. They are always stored on the blockchain. But we also store on the blockchain that against this token, the owner of this token is this person. And this person is basically some wallet address. So only that wallet address will be having the ownership to those tokens, and only that wallet address will be able to send those tokens to some other person or use those tokens to for some reason, right? So that is how we control the assets. The assets are never stored in your wallet. In your wallet, just two things are stored: your private key and public key. Okay, so I've just created a new wallet. I hope you all also have done that. And when I create it, I get something like this. I'm using Tezos mainnet and I'm having 0 Tez for now. Now I can receive it from someone. I can buy them. I can swap them. Swap basically means creating one type of token to another type of token. So let's say you have token X and you want token Y. So you will send token X to some exchange, and in return they will send you token Y. And it happens in a decentralized manner or sometimes centralized also. That is called swapping. And send basically means that you are sending some tokens, which we can't do right now because obviously we don't have it. Now in the main net, it's very difficult, right? I mean, not very difficult, but it's kind of you actually need to use real money to use tokens, to use the blockchain. But for this purpose, for the today's purpose, we are just trying to get along with the blockchains and trying to learn it, and we will also learn development on it, right? For developers, for testers, there are other networks also which are called the test nets. Every blockchain has some kind of test net, and the purpose of test nets are that the whole purpose is that you can use the network to test the blockchain or your application which is being built on the blockchain. testnet works exactly the same as mainnet. So that makes it easy. That makes it easy for being confident enough that if something is working on the testnet, it will also work on mainnet. Now, just one difference on testnet is that on testnet you can get the tokens for free, and that's very necessary because to use the blockchain you need some tokens. So that is why testnets are made so that you can get the tokens for free and then play it around. Right? So I'll just switch my network to testnet. Now Tezos have multiple testnets, and the latest one currently is Ithacanet testnet. And then before that there was Hangzhou testnet. Now these are the protocols. Tezos blockchain keep evolving. So the blockchain, the working of the blockchain is changed after each evolution. And that is why we always keep multiple testnet for each stage of evolution. So at Hangzhou, some things were introduced. This is the network for that. Then on top of Hangzhou, we got Ithaca. So for that, this is the testnet. And currently the mainnet is also using Ithaca. So the mainnet blockchain is working and Ithaca testnet blockchain is working is same. So we are going to switch to this one. And once I switch to this one, again, I don't have any tokens because I just have created that. I'll just rename it to just. Now, how do we get the tokens? That's a real problem. To get these tokens, the thing I can do is there are services called faucet. Now, the point of faucets are they are basically a kind of an open source of of accounts, or you can say an open source of uh, private keys, which you can import into a wallet, and those wallet will be having some tokens in it. So I'll show you that by example. So let's go to some faucet of Tezos. So let's go to it. Okay, just a second. I'll go to the faucet website. Second, I have that. Okay, it's not there. Yeah, one more thing. There's another blockchain explorer which is very popular. That is called bettercall.dev. It's quite similar to TZKT. I mean, it does the same job, but it's quite different. This is how it looks like. And again, we can explore multiple networks in it. Hangzhou is different, Ithacanet is different, and the mainnet is different. We'll use this when we are developing some application. That isn't working. Yeah, got it. Okay, so this is the website for getting the faucets for any test net. For Ithacanet, we got this one. So you guys can go to this URL. Can I get the YouTube link for this live share? Because I need to send this to the chat. Just search that. Because I need to send this. Or there we go. So once you go to this website, you can go to the Etherconnect faucet, and here you just need to do some capture. Just complete the capture real quick, and then I can click on Get Etherconnect Tez, and then you will get some kind of a JSON, right? And this JSON will be used to import a new wallet in your import a new account in your wallet, and that account will be having some tests. So the address of this account will be this. This is the mnemonic of it. Mnemonic is another name of seed phrase. I generally call it mnemonic only. There's some email for it. There's some password for it, and this is the amount of tests in it. This is some activation code. Okay. I'll just copy to the clipboard. Go here and click on the profile picture and click on import account. So here you can import account from various different using different types of importing techniques. Like you can directly enter your private key, or if you have some mnemonic, you can enter that. You can use a fundraiser, you can use a faucet file, which we are going to do. So I can either download this as a JSON file. Okay, I don't need to do that. I'll just copy it to the clipboard and paste it here. And once you paste the faucet JSON here, it will directly import that account into my wallet, and then I'll have a new account, which will not my main, but it will be usable. Okay, in the same manner as any other account. So when you create a wallet, it's activated, which is, I mean, in simple terms, you can understand it like the wallet's public key will be broadcasted to everyone. Okay, so yeah, once I import it, I'll just rename it as faucet account, and you can already see that I have got around 40,000 tests here. So now I can use this account for anything I want. So the first thing we can do using this wallet is to send some tokens, right? So let's try to do that. Okay. So what I'll do is I have this account. I'll send some tokens to my previous one. What is my previous one? The main account. Yeah, the test account. So this one have 0. This one have about 40,000. So I'll send 30,000 tests to my test account. So how do we do that? We need to know the address of the test account, the address of the account to which we are sending something, right? So this is the address. I mean, it's kind of trimmed from between, but I can click on it to copy that. Then I'll go to my faucet account and I'll click on send. Now the recipient is the test one. So it's already showing me some suggestion for it because that's already imported. But if you don't get any suggestion, you have to paste it here. Then you need to specify how much you need to send. Yeah, one thing that you always need to make sure is that this address should be correct. If you give any wrong address, then the tokens will be sent to the wrong address, and then you lose complete ownership to those tokens, to those crypto. And that is how you lose your crypto. So never send your tokens to some different address, some unknown or yeah, unowned address. Okay, and also never reveal your private key. These are some of the precautions you always need to take while you're dealing with blockchains. So I have inputted the correct uh, address. I'll specify how much tokens do I need to send. Let's keep it 30,000. And then you need to specify the fees. Now, what is fees? Whenever you are making some transaction to a blockchain, you need to specify some fees. And now the fees is some amount of money which you give to the bakers. I mean, bakers are doing the job, right? They are maintaining the blockchain. They are making new blocks, validating them, right? We have seen all sort of heavy processes that uh, nodes do, right? So they need something in return. So that is why whenever people make transaction, they add a small fee with it so that it can be given to the nodes and as an incentive that nodes keep doing what they basically do. This is the point of fees. Whenever you, like in case of Bitcoin, fees is taken by the mind. I mean, Bitcoin has some other algorithm for it. Okay, but in proof of stake, you have this method that you give fees as a transaction with the transaction, and that fees is taken by the bakers. Plus, there are some more um, crypto financial things which will take a whole kind of different lesson to explain that how incentives are given uh, to the bakers. I mean, if the token is inflationary, which means the total supply of the cryptocurrency is continuously increasing, then that new tokens are given to bakers. In simple words, one more thing, the bakers have a lot of transactions to add. They have a complete list in the mempool, right? So how do they decide that which transactions to add and which transactions to ignore for now? They decide it by the fees. If a transaction is having more fees, That means baker will get more incentive. That means the bakers always try to take the highest fee transactions to add into the blockchain, which means if you have given more fees with your transaction will be added to the blockchain even faster. And if you give very minimal fees to it, then your transaction will wait while the higher fees transactions are being added in the blockchain. And when they are done, then comes your turn. So fees kind of decide how fast will your transaction will be added into the blockchain. One more thing, uh, when there are so many transactions that, I mean, the whole world is using, and when the transactions increases and keep on increasing, and the speed of transaction is very big, much, much larger than the nodes can handle, then it kinds of get very competitive for the fees. This process is called congestion, which we generally see with Ethereum. So in that case, if you need your transaction to get through, basically if you need your transaction to get added into the blockchain, you need to give a lot of fees because there's much more competition. With Tezos, that isn't the case. The project is made in such a way that this doesn't happen. So you basically need to give very less fees, and even for the fast transaction, you just need to give 0.0002 Tez. So I'll just give the most amount of Tez because obviously all of this is free. So I'll click on send, and now 30,000 Tez is being transferred to this my main test account, and that will be the transaction. So what I'll try is let's set to minimal so that this transaction takes some time, and we'll observe this transaction into the explorer. I'll open the explorer tzkt.io. And just one thing, I'll go back. This is my faucet account which is having something. I'll copy this address. I'll go to the Ithacanet Explorer and enter this address so that I can take a look at it. I'll click enter, and this is my account. Right, I see the same address here. It's completely transparent, so anyone can look at it. And it was activated 8 minutes ago with this balance, right? We looked at it. Now, whenever I'll make a transaction, I'll come to this website and refresh that so that I can quickly look at the transaction which is being happened. Okay. So I'll send this just a second. Copy test address, then go to faucet account, click on send, enter the test address, enter the amount 30,000. I'll give minimal fees. Let's even decrease that. If no, 09, yeah, that should work. Then I click on send. Just send. I just wait for some time. Yeah, one more thing that we almost forgot. Whenever you are making a transaction, you need to confirm that, because I mean you are dealing with money, right? So you always need to confirm. So it will ask for a confirmation that what you are trying to do is sending 30,000 tests to this address, and that's a transfer operation. This will be the gas fees. This is the storage fees, which is a special kind of fees which is given because you are acquiring some storage into the blockchain. If you don't take this fees, people will freely acquire space inside the blockchain, which is very resource heavy, right? So there's always some fees for that also, and there's some storage limit that's automatically decided, and it's a limit to kind of specifier that will tell the nodes that how much storage is expected for this transaction to hold into the blockchain. And if you don't confirm, it will automatically time out. So I have to click again. And I'll confirm that. And when you confirm that, it will be signed also. So now the transaction is sent to the network. Just go here and quickly refresh that. And it's applied in no time. So here you can see that just 3 seconds ago, this transaction was done. And whenever you make your first transaction with the account, the public key of it is revealed. Okay, so activation is probably something different, but this is what happened. What is happening here? And we have just sent around $90 to my main account. Okay, now if I look at the main account here, I'll go back. It will also show us the success message that the transaction you just did is confirmed. It's added into the blockchain. And if I go back, now you can look here that 30,000 tests are removed from here and they are added here, right? Actually, the net amount which is removed from my faucet account is 30,000 plus the fees. And I received 30,000 here. So this is how you basically make a send transaction, right? If you want, feel free to send me some test tokens too, just to play with. Actually, right? I send my address into the chat. So let's see after some time if I get something or not. Right? So that is a very basic application of a blockchain, and I can even look at the transaction. So this transactions detail are given here, and I can copy the transaction hash, enter it here to look at the complete transaction, or I can simply click on this link and look at what happened here. So 30,000 tests was being transferred from this account to this account. This much fees was given. This is the counter, the timestamp, and I can copy the whole information through some JSON. So this is the JSON of the whole operation, and it contains all of the nitty-gritty details of core blockchain stuff. Like what was the protocol, what is the chain ID, what is the hash of the operation, which you can also look here, and what is the branch. Content is first content was revealed, but then we see the transaction. The source was this. This is the fees, counter, gas limit, storage limit, 30,000 as amount. The destination is my main one. There's some metadata also. So I mean, it's all the advanced stuff, right? Which we generally don't need. All we need is that who is sending, how much is being sent, and to whom is being sent, and this transaction is being confirmed. A confirmation, we basically mean that this transaction is added into some block. Okay, so that is the point of confirmation, because we already need to make sure that whatever transaction you have done isn't just stuck into the mempool, right? So it should be confirmed. There should be a green tick and applied. Right? This is the block where it was added. We can look inside the block. The block only contains one transaction, which is the same one which I did, and that is why it was done right away. In case of mainnet, things are happening too much. right? It's the real thing. So it is generally moved to mempool, and there's some time that is taken for confirmation. So I haven't got any test. I think you guys are having any problem. I don't see your address. Uh, I have just sent it into the chat. What do you mean? Okay, there are some questions. I'll just cover them once we have covered everything for wallets. Okay, we'll just keep waiting for that. I'll just explain some more stuff of the wallet. So on a smart contract based blockchain, people can make their own cryptocurrencies, right? And like on Tezos also, there are so many cryptocurrencies. Uh, Kalam, Doga, these are the crypto tokens which are very popular. Plenty, right? These are tokens which are quite popular on Tezos blockchain. So you can also hold those tokens too. And if you hold them, then it will be listed out here. Currently, I just have Tez, so that is all I have here. Okay. Collectibles are the NFTs, the non-fungible tokens. If you have any idea about NFTs, they are kind of basically non-fungible token is a self-explanatory name, which means there are tokens which are non-fungible. That means if you have two NFTs of same name, then they will have different values because that's the purpose of it. Right? There's some kind of application of it or its purpose which makes them different, and hence the value of them is also different. So they are generally exchanged with some fungible tokens, and you basically can't exchange, or you shouldn't exchange some non-fungible token with some other non-fungible token. Those are the NFTs. NFTs are kind of media, any kind of metadata thing, maybe your personal identity, maybe some artwork, some image or video or anything. And we can also look at the previous activity which we have been doing using this account. So the test account recently got 30,000 tests 7 minutes ago from this person, and this is the operation hash for it. Operation hash is a unique string of that operation, which uh, which is generally used to uniquely identify any kind of operation. If you, let's say, if you asked some cryptocurrency from your friend, and your friend is claiming that they have sent that, so as a receipt or as a kind of way of checking that whether the where is the transaction currently, maybe the mempool, maybe it's some wrong transaction, you can always ask for the op hash and then look inside the explorer. Or if you have the uh, friend's address, wallet address, you can also copy that and paste it here. So you can paste any kind of unique hash or something in this search bar, and you'll get the knowledge of it. Okay. So well done, guys. I got 298 tests from someone. Let's see from who I got it. Okay, I'll refresh that. I'll load it more, the activity. Okay, it's not loading. Let's simply copy this hash and go to the um, explorer. And this is the thing. 1 minute ago, someone sent me 298 tests, and who sent it? This person sent me. This is the address who sent me something, who got around 2 tests now. Okay, so this address also was having around 300 Tez 16 minutes ago. So I can trace it back that who sent this person some Tez. I can trace that back also. You're getting my point. So I I go to my account. I see who sent me. This is the person who sent me 300 Tez, and this person also got those 300 Tez from someone else. Now, who's that someone else? This is someone else. I'll go to this person, and this account was uh, activated around 20 minutes ago with 43,000 tests. So I think whoever is doing this is following the same procedure. They also have some main account. This was that person's main test account, and then he imported some other account, which is this one. He first sent 300 tests to its main one, and then sent 298 tests to my account. So this is all that happened, and that is why the transparency is so good, because you can always trace everything back. You can always look at the blockchain that what is being happened. Everything is transparent, right? So again, there's no point of corruption. For example, let's say if my friend can even lie that okay, I don't have 43,000 tests. I just have 400 tests, and out of 400, I'm just giving 300. So I can always look that address, and uh, its balance is transparent if you know that address, of course. So I think you have got pretty good idea of how to use the wallets. I think it's a fair time to take the questions. Let's start it from the beginning. Somewhat, somewhat. I mean, you will have some uh, knowledge gaps in between. Is there any alternative? For example, there are a lot of alternatives. You can even make your own wallet. It's all open source. There are many types of libraries which will help you to make your own wallet. But that's not officially recommended because it can have security issues. So Nan wallet is a very good wallet. Nan is yeah, you heard it right. It's the dish naan. Uh, and it's a mobile app. It's on iOS and Android both, so you can download it from Play Store or somewhere and use that. Temple is mostly used with Tezos blockchain, and I don't remember any other currently, but there are for sure. I'll just make a quick Google search that whether we have anything Tezos wallet. Temple Trust wallet is another kind of Tezos wallet. You can also use the a command line interface, Tezos client. There's a command line interface which you can download and use on your Linux and Ubuntu machines. So it's directly operated from the terminal. So there are many other types of wallets, and you can use any one of them according to your will. Ledger is the same thing as hardware thing. If we got any time, I'll show you the ledger also, but it will probably it's a whole another lesson actually. So the seed phrase has only 24 words for it. Always wanted to know the working seed phrase in one. Okay, the seed phrase was actually included. The proposal of it um, is in the Bitcoin improvement proposals. It's BIP 34, I think. I don't remember. Maybe BIP 39 or 34, which is the latest one, which specifies the complete algorithm of it. I'll just Google search that if it's BIP 34 or BIP 39. BIP 39 mnemonic algorithm. You can use the code of it. There's a library if you use TypeScript or JavaScript, it's Web39. That's a simple package name, and you can use this mnemonic generation. Okay, you can read it about from here. I don't think it's easy to remember how. Personally, I don't. I just write it down. Is seed phrase auto-generated? Yeah, it have to auto-generate. If it's asking for you to generate, humans are terrible at making random things. So it's like completely recommended to auto-generate it in a randomized fashion using some computer. Because if I give you the chance of making your own seed phrase, you'll kind of make some pattern which will be relatively easier to guess. Is different in number of coins common? I received 9K while you received 39. Yeah, it's very common. From Faucet works in their own way. The community manages it, and they have their own kind of complete working. And it's very common to have any kind of unpredictable amount in it. But it's generally more than enough. If you're making any kind of big project, you generally don't need more than 1,000 tests. So if you're getting more than 1,000 tests, that's enough. I mean, look at the gas fee; it's very small, so you don't need much. 9K is okay. I once received some more than a lakh tests, maybe 1,39,000 something. So it's quite common. Did I receive anything else? No. Okay. All right. So that was a basic understanding of using a wallet, setting it up, and sending some tokens to making a very simple transaction. Now, one more. Now let's come to some generalized things. Okay. So when Bitcoin was introduced, this is all it was capable of. It was capable of just making transactions of Bitcoin, sending it, receiving it, and mining it. Then a genius named Vitalik Buterin kind of generalized that thing, and he introduced Ethereum blockchain. And what we have in Ethereum is that you can code your own process which can happen inside a blockchain. Now, currently, the only process which happens inside the blockchain is transaction, money transaction. You send some money from one account to another account. So every account has some balance, and whenever you send it, the balance is subtracted from the source and it's added to the destination. That's all which is being happened. But you can use blockchains in other applications also, which you can make, and that makes it very generalized. And this is it introduced in Ethereum. So now you can make your own code, which other people can use using their own wallets, and that way you can store any kind of data, not just numbers of amount, how much tokens a person have, but any kind of data which you will code, any pattern of data, how you are storing it, how much you are storing it, and then make computation, calculate or make algorithms along with that data. So you can basically code your own procedure inside the blockchain. Now, it's kind of hard to understand. I mean, I also took some time for that. So I'll explain it. You'll get it while we are developing. For now, all you can just remember is that you can add your own set of rules, which will help to. It's like hosting your own backend on the blockchain. Yeah, that's a very simple way to understand. You made a backend and you hosted it on the blockchain. So now on backend, what do? We make API request using HTTP protocols, and you make send it, you make get request, you make post request, right? The same thing can be done on blockchain also. If you host your backend on the blockchain, you can you don't need to make get and post HTTP request, but you make transactions using a wallet. That is the only difference, right? So now you can specify your own logic, your own algorithms in your backend, and it will work the way you want it. So now not just the transactions are done, not just the transactions of money is done, but any kind of transaction that you will code. So that is a smart contract. The algorithm, the backend, the code you are hosting, that is called a smart contract. Okay. So we'll start smart contract. There's some theoretical stuff with smart contract. So smart contract are the code that can run on a blockchain, right? And you can understand that smart contract as a simple class. What is a class? Class in terms of OOPS, object-oriented programming. So a class is kind of a uh, enumerated code, right, which have its member variables and which have its member functions, right? So these are two things. So for variables are used to store the data, and functions are used to make operations on the data which is stored, right? That is all a class do. So whenever you host a smart contract on the blockchain, you just simply make a class, and when you make a class, you specify some of the variables that we need to store this, and you specify the functions which other people can call and while they are making a transaction. Okay, so they have to make a transaction. Still, they need to give the fees. Still, they have a choice of sending some Tez or not, but they will also specify the name of the function which they are calling in the smart contract. Okay. So without the smart contracts, for example, in Bitcoin, we we just have a money ledger. Okay, we have the names of the people which are the address of wallets, and against that name we write a number that this person got this much money, this person got this much money, this person got this much money. When you make a transaction, you simply reduce the money from the source address and add that money to the destination address. Um, so one more thing is uh, this whole process of making money transaction is somewhat manual. Okay, now how is it manual? It's it's more like when you need to send some amount, you need to make a transaction. You are actively doing something using a wallet. That's kind of semi-automated. I mean, you are initializing it, and then it's happening in the blockchain. Smart contracts enable us to make it automatic, which means you can even write code which will automatically uh, transfer the tokens from maybe from smart contract to some other person, or from one smart contract to some other smart contract. So you can kind of automate it if the smart contract have some balance. Smart contract also have their own balance. That's the next point. Uh, so smart contract is a code which resides on the blockchain, right? So this is the blockchain. and you have just posted their own code. Now, whenever you deploy your smart contract into a blockchain, it goes in some block. So this first this smart contract was deployed, then in the next block this one, then in the further blocks there was no smart contract, just some usual transactions, and then we got another smart contract. Now, um, smart contract can have functions, it have variables which is used to store the data, and I like to call them as robotic wallet. Now, why do I say that? I say why do I say that? Because smart contracts are very similar to us. We are humans and we have our own wallet. And whenever we need to make some transaction, we we have our own balance in the wallet. We have our own tokens in the wallet, and we make a transaction using our wallet. Smart contracts are also kind of similar. They also have their own balance. They can hold some tokens. Their wallet also have a very similar address, right? So whenever you need to send some tokens in a smart contract, you just specify the address of the smart contract and send the tokens. So that tokens will be taken by the smart contract. It will be locked inside it. And those tokens will only leave the smart contract when the smart contract runs that code to send the cryptocurrency to someone. Until then, the tokens are completely locked in. So that makes it uh, very similar to a human handling a wallet, but it's just not a human; it's a code, and they have their own address. Yeah, we can store the money. And one more thing, whenever you have a smart contract and if it has some variables in it, and the variables are holding some value, and let's say you made a transaction, you called a function, and that function changed the value of some variable inside the smart contract. That means we are changing the value which is stored inside the blockchain, which is only possible when you're adding that address into the block. So this is called a state. A state is these variables are called the state variables. So uh, whenever you have the value stored in the variables, the state variables, that is a complete state of the smart contract. And if you are changing any of the value of the variables, you are changing the state of the smart contract. And in that case, the whole state is again copied in the blockchain. Now, this is way more optimized in the real case, but in as a basic understanding, you can just understand that the state is again saved in the blockchain. And now let's talk about gas. So a very simple way to explain gas is by taking an example. Let's say in a function, you wrote a code, and in that code, you just write an infinite loop. You just wrote while, true, and empty braces, and it can keep on running. So when someone will call that function, that code will keep on running. Now that is a very disastrous process, because if you ever post any kind of smart contract, it will completely just keep running, right? And it will uh, kind of blocks the whole blockchain, because then the node will keep on running the infinite loop. So in order to prevent that, the concept of gas is introduced, and in gas you you can usually interpret gas as the normal gas of cars, right? So you fill the petrol or diesel in the car, the car runs for some time and it only runs how much gas it's having and what is the average of it, right? So that is the point of gas. Gas is kind of a fuel which is specified with a transaction that while a function in the smart contract is running, it have just some limited amount of gas, and whenever the node will be making some computations, very low level computations which are in assembly language, that add or add, jump, write, read, these are the very small operations which keep on happening uh, uh, when you are doing some when you are running the code, right? So for each operation there is a specified gas amount, and the more operations you will be doing in a code, the more gas it will consume. So whenever you deploy a smart contract, you also specify the amount of gas, that this is the amount of gas uh, this smart contract will always take, and it will not take more than this. So this way, even if the smart contract have some infinite loop, it will eventually run out the gas, because the operations will keep on going, the gas will keep on decreasing, and at some point the gas will be finished. And when the gas is finished, the node knows that okay, the limit of working on this smart contract is over, so it will simply fail the transaction. And whoever called that function, uh, that calling that calling process is reverted back, the transaction is paid. So that is the point of gas. It prevents the extra usage of nodes resources, computation resources. So that's all explained here, that the more code runs, the more incentives the node should get, right? And gas is used to measure the computations of smart contract. If it's taking more gas, that means the smart contracts are uh, doing more computation. And deploying a smart contract with more gas, you need more fees, which means as a developer, if you have coded a smart contract, it's better to optimize that, optimize the smart contract. If you are uh, writing way more unoptimized code, then it will be very heavy for you to deploy it and for the people to use it. And when someone makes a transaction, they have to give some extra money as gas fees. That is the money we are talking about. Heavier codes needs more gas, and that is the point of gas. Always need to reduce the gas consumption. Smart contract should be efficient, right? Now, let's also talk about dApps. dApps is a small, it's a smaller name of decentralized applications. It's very similar to normal applications which we see in the real world. The the only difference is the application have some part of it decentralized, which means some part of your application is hosted into the blockchain. For example, if you are, if you let's say if you have made some game, it's a very basic game, like what example should I take? Let's say it's Counter Strike. Okay, it's CS:GO, Counter Strike. So in Counter Strike, you have your own skins for guns, right? Now, the skins have its own marketplace. People buy the skins, people sell the skins, and there is a whole market of it. Now, you can just take that skin thing and put it into a blockchain as NFTs. That will be just the decentralized part, and the rest of the game can be centralized. So this is a hybrid mixture of centralized and decentralized. And that way you have made a decentralized application. Sometimes the whole application is also just the complete application is hosted on a blockchain. Nothing is centralized. That is also an application of decentralized application. Whenever some part of your application is interacting with the blockchain, it's a decentralized application. And whenever you need to interact with the blockchain, you generally need to code some kind of smart contract, because that way only you can customize the way you want it to work. And traditional web to websites have a front end and a back end. Dapps are front end plus smart contract, or you can also have a back end, or you can have your own kind of centralized database, MongoDB or Postgres or MySQL. There are too many examples of dApps. I mean, we see hundreds of new dApps every day. It can be NFT marketplaces, it can be decentralized polling website, it can be games. There are many types of games which are decentralized and which are hosted. You might have heard about CryptoKitties. That is a dApp, and it's kind of a combination of NFT marketplace and a game. And you might have heard about uh, Dogami. That is a very popular uh, metaverse type of game on Tezos. There is Decentraland, there is Sandbox, there is Upland. So many new games and NFT marketplaces which are uh, like booming currently. Okay, so these are all the decentralized applications, and it have its own ecosystem. People interact with it using the wallets only. Like um, I'll also give you a very short introduction to DAOs. What are DAOs? I mean, it's a quite popular word which is being used in many places. So I'll just give a brief introduction to it. DAO is basically a decentralized autonomous organization. It's like the way I like to compare it is it's basically a company, but on Web3. It's a company on uh, in a decentralized manner. So, like a traditional company in Web2, it's private, it's closed, it's less transparent, it's centralized. The whole power is inside the company, and it's difficult for people to join the company, and that is the point. But still, the people inside the company follow some rules and do some work in a specific direction, right? DAOs kind of do the same thing, but in a decentralized manner. It's a set of people which are working in a specified direction for some goal or something, but anyone can join a DAO. And a DAO is like a staking system too. It is like a DAO have its own coin. So whenever you need to join a DAO, you buy their tokens and you lock your own cryptocurrency into a smart contract. Now, other people also will do the same thing. They will lock their cryptocurrencies into their smart contract, and the smart contract will, in return, give some custom token to the guys. Okay, so now everyone have given their own money into the smart contract, and a kind of a proof that you belong to that DAO. Now, the more tokens you have, which means the more money you have invested in it, the more power you will get. So DAOs have its own voting mechanism. Whenever the DAO needs to make any decision, it's taken using the method of voting. A simple poll is run, and the more stake you have, the more weightage your vote will have, right? If you have, let's say, more than 50% of the tokens, that means you have more than 50% of the power. That means you can basically you can basically have a complete power over the DAO. DAOs generally don't have we generally don't observe this kind of thing. DAOs are very massive, and it's a whole. It can be a whole community. Okay, and they continuously work in a certain direction. So these are the DAOs, right? They have their own smart contract for handling the decisions. Uh, they are used by the tokens. The tokens are like a ticket, right? And to distribute the tokens, there is a process which is generally used. I mean, there are other processes too, but ICOs are one of the popular ones. Like ICO is a full form of short form of initial coin offering. It's just like initial public offering that we see in general stock market, right? Some new shares are made, and it's a part of it, right? It's distributed to people, and people can buy it, sell it, make a complete market out of it. The same thing happens with ICO too. A new token is made, and that token is made available for public to buy. And when they buy it, they can also sell. That's it. That's ICO. Now all of this is kind of it's a bit practical. Like you won't understand the point of it and the intuition of it until and unless you see it happening or be a part of it. So I'll highly recommend to keep exploring these DAOs and ICOs, and that is the way you will learn about it. Just like looking at the slide, it's very difficult to understand. And I'll just show you some example if I can look at it. But before that, I'll just take some questions. Will gas be reverted for the failed transaction? Yes, it will. How long it will be? For the transaction is not much long. Or if you are talking about the session, it's going to end by 9:30. So the last thing which is left now is just to look at some of the decentralized applications so that from tomorrow we can just get started with it. Get started with developing, right? So let's see what application should we go to. There's a good project which is being made currently. It's named as Origin X Games. Okay. This is a project which is being made from Tezos India College. So it's basically kind of a game that it have a cool concept. You basically buy some land, you buy some blocks, and then you use the blocks to build something on the land which you have bought, and then you can sell that part of the land to other people as an NFT. That's the whole point. And whenever you go to any decentralized application, you need to connect your wallet to that application. And connecting your wallet is a simple process, which basically means that you will allow the website to read your wallet, your wallet's address. And once they will get your wallet's address, they will get all the information about your wallet. So that is generally needed because they need to get some, because sometimes your application will need the user to have some tokens. So you need to uh, get that information, that whether the user is having those tokens or not, what is the amount of those tokens, right? That's everything. So you need to connect your wallet whenever you're going to some decentralized application. In this website also, I'll connect my wallet. So I'll click on connect wallet, and there's some terms and condition. I'll accept that. Then it will ask me for the options that what wallets do you want to use. I have a Temple wallet, so I'll click on Temple wallet. Then it will ask for my password. Enter the password. And then it will ask me that from which account do you want to connect with. Okay, so currently uh, this project is hosted on the Hangout testnet. That is why it's telling me that it's Hangout testnet. And on Hangout testnet, what account do I want to use? Now I don't have any of the tokens on any of the accounts. So let's just cancel it for now. Let's add some tokens on the Hangout testnet also, because we did that with Ethaka. Let's do it by Hangout. So again, for again forgot the faucet website. I think it was this. So yeah, good. Let's say if we have Hangout. I don't think Hangout is supported. No, it's not. So that means we cannot use the application, but this not much of a big deal. We just wanted to connect the wallet, and that's mostly the common case with all of the smartphone apps. I'll just click on connect, and it will show me that I've granted the permission, and then it will show the address of it. Right. Let's say if we have any other project, there's a website for it. Projects. Let's see. Yeah, we can go to recommend also. Let's go to object. So objkt, or I also call that object, is a kind of NFT. It's like a OpenSea of Ethereum. NFT marketplaces. The marketplace of NFT marketplaces is like that. So whenever you go to some tab, the first thing you, not the first thing, but mostly the common thing you need to do is connect your wallet. And here the sync word is used as connect. So I'll just connect my Temple wallet here to the same stuff. I don't have anything in this. Let's say I connect. There's no point of it. I connect it with my real account. Let's go here, open object. Right, we can go to program. So let's log out. Do it again. I'll click on sync. Go to the connect wallet thing. Enter the password. And then in the the mainnet, I got some Tez in my main account. I'll click connect, and it will ask for me to sign something. So for some website, you need to sign some bytecode using your private key. So this is the pop-up which Temple Wallet gives us. I just need to click sign. That will sign it for me. So that's very convenient. You don't have to go into any kind of cryptographic details that how is it being happen, right? all of that is automated, and I just need to click on the button. Signature is done. This is the signature, and now you can see my profile here. So I can go to my wallet. I don't have anything for now. Actually, I have the original certificate. Yeah, I have this only. And there is another token which is OXTZ, which is kind of a replacement of XTZ for object, I think. I can go to my profile and it will take um, all the information of my profile. So I have a bunch of certificates and right. You can use all of the information which is along with my work. Okay. Same thing is happening here also with Togami. Bunch of cute dogs. Can connect my wallet again. I've used Temple. So this is the usual stuff which you generally do. You go and connect your wallet and do the stuff. That is the case when you are dealing with decentralized applications. Yeah, on traditional systems, the purpose of connecting wallet is using authentication. You authenticate yourself using your username or email and password, or OTP, right? Your mobile and OTP, or sometimes your what is that called? OAuth password, right? So these are the things which we generally use for authentication in traditional Web 2 systems. But in Web 3, in decentralized application, the same thing is done using wallets. When you connect your wallet, that is all that's needed for you to authenticate yourself. So when you are authenticated, that means you have when you're connected, that means you are kind of authenticated, and when you disconnect, that means you have locked out. So for now, you would have got pretty clear idea of how dApps work and how we can interact with dApps. When you just simply connect your wallet, uh, I'll show you one more thing so that you can get pretty clear idea. So there is an application on Ethereum called PancakeSwap. PancakeSwap is like a decentralized exchange where we can exchange our different assets. So I have some main assets in my MetaMask wallet. It's a wallet for Ethereum blockchain. Okay. So I connect my MetaMask wallet in this uh, app, and when I connect it, this is my current balance, right? And then whenever you need to make a transaction, you set some things. Um, let's say I want to exchange craze with cake. Let's say one craze with cake, not cake. Let's say I want BNP. So this is the transaction I want to make, and then just one more thing. Let's make it out more. So settings. Click on enable Grace, which means I'll give my permission of using Grace to this website. So this it will ask for me to give the permission of Grace is basically a token. So I'm giving permission to this website. And always before giving any permission to a website, always you need to check that if the website is correct or not, because there are many phishing cases where the website looks exactly the same, but it's not the original one. So always check the URL, and it will also give you some uh, warning if the website is not much popular. So currently it looks good to me. So I'll confirm, and by clicking confirm, I'm basically giving permission for some of my assets to this website. I click on confirm. So this is kind of a complicated project, and you don't need to understand it in the first go. But when I have enabled that, I can click on swap, and this is where it will ask for confirmation. I'll confirm that, and then it will make a transaction into my wallet, which I just need to sign. These are the details which is being happening here. Okay, I can look at the data, which will probably not make any sense. Once you have everything confirmed, like you have validated everything and everything is correct, then you simply click on confirm, and that will inject the smart contract into the blockchain, and then you basically just need to wait for some time to confirm to let it go into some form. Okay. But I don't want to make this transaction currently, so I'll just click on reject. Okay. So this was all of smart of tabs, wallets, basically how the whole Web3 ecosystem works. Okay. If you have any questions, I think there was some. Well, guess please. Okay. Yeah, there are no questions. If you have any questions, you can type it now. We have some time for that.
If there are no questions, shall we move to today's quiz, or is there anything you want to cover before wrapping up?
No, I think for today everything is done. We can move on.
Okay, so if there anyone has any doubt, please drop them in the chat box. Otherwise, we will just move to the quiz. I have prepared this. Yes. Okay. Just so you can turn your screen, screen sharing off. I will just share. I guess my screen would be visible. Everyone join the quiz so that we can start soon. From tomorrow onwards, you will be working on projects, so keep your handsets ready. Obviously, if you want to tell something like prerequisite or anything you want to get them to get ready before you can start off.
For tomorrow, just make some GitHub repository where you can code along with me, and make sure you have installed TypeScript setup onto your computer. That will be done on the 5th day, not tomorrow. For tomorrow, there's nothing much because tomorrow we'll be coding on a web ID only. So you don't need to install anything. Just set up your wallet and everything which is being done today. And yeah, that's it.
Then we'll let the others join. How many participants do we have? Right? We'll start the quiz at 9:23 p.m. All the best to everyone. Let's see who aces today's game. Only one participant is remaining to end the quiz. Then we will show the leaderboard. And yes, we have, I guess, we have pre-decided winners today. Kudos to Siddharth Das Gupta. We will end the quiz at 9:35 p.m. So the quiz has been ended. And kudos to Siddharth Das Gupta for acing today's quiz. And now I show yes I want to end the show. Let's see the leaderboard. Then at the first position there is Siddharth Das Gupta, followed by Himanshu Kushwa, and then followed by SB. All kudos to everyone. And now we come to the end of the session. Now one more thing, all of you from tomorrow be more interested, be more interactive and participate more, because from tomorrow you will be developing blockchain in the real world. And that's all. If you have any questions, you can type in the chat box now. So we will wait for a little while, like around 9:34, and then we will end today's session. Is there anything you want to chat before ending today's session? I guess if there are no comments, we can end. Thank you everyone for joining. That's all for today. See you next time. Bye bye, everyone.